Welcome to the second video for 20.1 where we're going to look at how to draw cell diagrams. So cell diagrams are a shorthand for showing what's happening in the cell, because it's a pain to draw the cell diagrams out properly because it takes a long time. So if we can do this shorthand, it saves us a lot of time. So in these diagrams, a vertical line is going to represent a phase boundary. So for example, between a solid and solution. And if you've got the double vertical line, that represents a salt bridge. So here is an example of a typical cell where you've got a zinc half cell and the copper half cell. So this salt bridge here, we draw a double line to say it's in the middle. So what we're going to end up is this, but I'm just going to show how we get to that. So this double line, that's our salt bridge. And then zinc's the most reactive. So because that's more reactive than the copper, the electrons are going to go this way. So the zinc is going to, so the reaction we've got here is the zinc's going to go to zinc 2 plus 2 electrons. So we write this how the reaction happens from left to right. So you have the zinc, and then we've got a phase boundary between the zinc electrode and the zinc 2 plus solutions. So we have a vertical line there to show between the zinc and the zinc 2 plus to show that there's a phase boundary. You've then got the Zn2 plus. We've then got a boundary between them because we've got the salt bridge. And then on this side, so on this side, the copper 2 plus is going to accept the 2 electrons to become copper. So it's copper 2 plus. And then we've got a phase boundary for that because we've got the phase boundary between the copper 2 sulfate solution and the copper electrode. And then we've got copper there. Okay, and if we want to calculate the cell voltage for this, so if you look up the EMF values, it's going to be the right-hand side minus the left-hand side. So it would be the voltage of the half cell of the copper minus the EMF of the zinc half cell. So sometimes it can be a bit more complicated. So if we've got platinum electrodes, then we need an extra bit here. So here we've got, so whatever we've got on the left-hand side, we have the electrons going round to that way, even if it's not what actually happens. So normally we'd put the most reactive on the left-hand side, but when it's a standard hydrogen electrode, that always goes on the left-hand side by convention. So because we've got a platinum here, we need an extra bit there. So because the electrons are being given up, what we've got here is the H2 is going to give up to become 2H plus 2 electrons. And then here we've got the magnesium accepting the electrons. It's Mg2 plus 2 electrons to give Mg. So we need to write this out here. So we've got H2. So H2 is the gas, and then the H plus is in solution. So we've got a phase boundary there. So I've got H plus, and we don't put numbers in front when we do the cell diagrams. So it doesn't matter that I've got H2 there and H plus there. Then I've got my double line because I've got a salt bridge. And then I've got my Mg2 plus. That's got a phase boundary between that and the magnesium electrode. And then there's nothing on the side here. So we have to be careful when we're drawing, that we need to draw an extra line here if we've got a platinum electrode. So the other example you might have here is if you've got, so for example, you've got an equilibrium between Fe3 plus and Fe2 plus. So I'd have an electron on that side. So if you had this equilibrium here, you'd also have a platinum electrode. So if that was on the left-hand side, I'd write it as it'd be then giving up the electrons. So the platinum would be, so it would be Fe2 plus, and then because they're both in aqueous solution, there's no phase boundaries. So if they're in the same phase, it's normally a solution, then you put a comma. Then you've got the salt bridge, and then you'd have the other side. Now, if this was on the right-hand side, of one of these cells, then you'd have platinum on that side. And then these would be the other way around. So you'd have Fe3 plus there, and then you'd have a comma, and then you'd have Fe2 plus on that side. And then you'd have a salt bridge there and whatever's on the left-hand side. Okay, thank you for listening. See you next time.